Here is an example to find distance between the two ships. So in this case, we may apply sine law or cosine law. The question is, two ships leave port at 5 p.m. One is headed at a bearing of north 35 degrees east and is traveling 10.2 miles per hour. The other is traveling 12.5 miles per hour at a bearing of south 40 degrees east. How far apart are they at 7 p.m.? So the ships leave at 5 and we want to find distance between them at 7 p.m. That means we're talking about time of 7 minus 5, which is 2 hours. Now since the speed of these ships is given to us, let us say ship 1 speed is given to us as 10.2 miles per hour. So distance traveled in 2 hours will be 10.2 times 2, right? So that gives us a distance of 20.4 miles. As far as the other ship is concerned, for the other ship, the speed is 12.5, right? So S2 is equals to 12.5 miles per hour. So the distance traveled by the other ship will be 2 times 12.5, right? 12.5 times 2, which is 25 miles. Now, we need to find distance between them. So let us sketch the diagram to represent the position of these ships. So let us say this line represents north-south and this is east-west. Now, one is headed at a bearing of north 35 degrees east. It means from north we have to move 35 degrees east. So that is the bearing, right? So in this bearing, this is the ship moving in this direction. And what we found is that in 2 hours it travels a distance of 20.4. So let us say the position for the ship after 2 hours is right there. Then this distance will be 20.4 miles. The angle is given to us as 35 degrees. So let me write 35 degrees here. Now the second ship is traveling 12.5 miles per hour at a bearing of south 40 degrees east. So this is south and from there 40 degrees towards east. So let us say this is 40 degrees towards east, right? So this angle for us is 40 degrees. Now it says in 2 hours it is going to travel 25 miles, so slightly longer than that. So let me just extend this line a bit more, okay? Not so nice, but well, that's the final position. Let us say after 2 hours, and let me label this distance here as 25 miles. Now we need to find the distance between them. So the distance between them is this distance. So let's call this distance as D. Now from the given situation, we can find the angle in between. That is 35, this is 40 degrees. So the angle in between, let's say theta, should be how much? Now this angle theta should be equals to 180 degrees minus 35 degrees minus 40 degrees, right? So that is 180 minus 35 minus 40. 105 degrees. So angle between them is known to us, the two sides are known to us. We need to find the third side, that is the distance, correct? So since we know two sides with included angle, SAS, we should be using cosine law, right? So using cosine law, we get distance D. So we can say distance D square is equals to square root of square of these sum of these distances, which is 20.4 square plus 25 square minus 2 times 20.4 times 25 times cosine of the angle, which is 105 degrees, right? Square root. So that is the distance, right? Since we do square root is the distance. So let's figure it out, how much it is. So it is 20.4 square plus 25 square minus 2 times 20.4 times 25 times cosine of 105. That gives us 1305.155 square root, and this is equal to square root 36.126. So we'll say 36, approximately 36 miles, right? So the distance between them is 36 miles at 7 p.m., right? So that is our answer. So the answer is 36 miles. So in such problems, it is important to sketch the scenario, and we can apply distance. We know the triangle, distance, speed, and time. That gives us the relation which we calculated, right? So we use this triangle. Distance is speed into time. Since we knew the speed and time was 2 hours, we knew two sides of our triangle, and that helped to find the length of the third side, which represented the separation between the two ships after 2 hours. I hope that helps. Thank you.